Hello students, let us continue the session on revision of the chapter surface area and volume. Fifth question, water flows at the rate of 10 meter per minute through a cylindrical pipe 5 millimeter in diameter. How long would it take to fill a conical vessel whose diameter is 40 centimeter and the depth is 24 centimeter. Here it's a cylindrical pipe, so the area of cross section will be pi r square. Area of cross section multiplied to the speed will give volume of the water flowing. So here, what are the given things? They have given for a cylindrical pipe, the radius is 5 millimeter divided by 2 because the diameter is given. When we convert this, it will be 5 by 2000 meters. In other words, it will be 1 by 400 meter. This is the radius, and they have given the speed. Speed of the water flowing is 10 meter per minute. When I convert this in terms of a second, it will be 10 by 60 meter per second, which is 1 by 6 meter per second. And for the cone, they have given the radius of the base is 40 meter, so 40 centimeter, so it is 40 by 2, which is 20 centimeter. It will be 0.2 meters, and the height is given as 24 centimeter, and this becomes 0.24 meter. So now we have volume of water flowing and also volume of the conical vessel. They both should be equal. So volume of flowing water equal to volume of conical vessel. We need to multiply area with the distance. Area of the base into the distance will give the volume. This will be equated to 1 by 3 pi r square h. Area is pi r square into v into t, means this is taken as v, velocity. This will be equal to 1 by 3 pi r square h. On observation, you can cancel this pi, so t will be equal to 1 by 3 into r square is 0.2 into 0.2 into height is 0.24 divided by r square. It is 1 by 400 into 1 by 400 into the speed is 1 by 6. We will be getting t as 510 divided by 10, 512 divided by 10, which is 51 minutes and 12 seconds. Because this will be 51.2. Question number 6. A heap of rice is in the form of a cone of diameter 9 meter and height 3.5 meter. Find the volume of the rice. How much canvas of cloth is required to just cover the heap? Here, the heap is in the form of a cone and they have given the diameter, hence I can find the radius. It is 9 by 2, which is 4.5 meter, and the height is given as 3.5 meters. So the volume is 1 by 3 pi r square h, which will be 1 by 3 into 22 upon 7 into 4.5 into 4.5 into 3.5. We can simplify this. 1.5 times is 4.5, 7.5 is 3.5. So we'll be getting 74.25 meter cube. This is the volume. Now, to find out how much canvas is required, we need surface area. The area of canvas will be equal to the curved surface area of cone, and the curved surface area of cone is given by pi RL. So we require the slant height. The slant height is given by under root r square plus h square. Here root of 4.5 square plus 3.5 square. 4.5 square is 20.25. 3.5 square is 12.25. We get root of 32.5. We need to find the root. It will be 5.7 meter. Therefore, area of canvas required will be equal to pi value 22 by 7 into r value 4.5 into L 5.7. On simplification, we get 80.61 meter square. So approximately 80.61 meter square of canvas is required to just cover the heap. Question 7. A factory manufactures 1 crore 20 lakh, 1,20,000 pencils daily. The pencils are cylindrical in shape, each of length 25 centimeters. So the height of the pencil is given as 25 centimeter. And the circumference of its base, circumference of the base is 2 pi r. This is 1.5 centimeter. Determine the cost of coloring the curved surface area of the pencils manufactured in one day at the rate of rupees 0.05 per decimeter square. Here I need the curved surface area of one pencil. This will be equal to the CSA of cylinder. It is 2 pi RH. 2 pi r value is known and h value is also known. So it is 1.5 into 2.5 centimeter square. So the curved surface area of 1,20,000 pencils will be equal to 1,20,000 to be multiplied with 1.5 into 2.5, and we get in terms of centimeter square. This we need to convert in decimeter square. So I can divide it by 10. So this becomes 1,20,000 into 15 into 25 divided by, this will be divided by 10, divided by 10, it becomes 100. One more 10 I will convert, I'll take, this becomes decimeter square. So 600 into 75 decimeter square. So the cost of coloring will be equal to rupees 600 into 75 to be multiplied with 0.5, will be getting it as rupees 2,250. Question 8. Water flowing at the rate of 15 km per hour through a pipe of diameter 14 centimeter into a cuboidal pond which is 50 meter long, 44 meter wide. In what time will the level of the water will be raised by 21 centimeter? Here, area of the cross section of the pipe I'll consider as A. This will be pi r square because it's a circular pipe. Pi value is 22/7 into the radius. They have given the diameter, so the radius is 7 centimeter. In meter, if I consider, radius will become 7 centimeter, which is 0.07 meter. I have to divide this by 100, so 0.07 into 0.07, this will be area of cross section. Here they have given the speed of the water, I'll write it as velocity of the water, V, 15 kilometer per hour. This I'll convert this as meters, 15,000 meter per hour. So here volume of water will be equated, water flowing will be equated to the volume of same water in pond. It is a cuboidal pond, so LBH will be the volume. Area into velocity into time will give the water flowing, so time will be LBH. L is 50 meters into 44 meters into 21 centimeter is 0.21 centimeter divided by here we have the area, it is 22/7 into 0.7 into 0.07 into 0.07 into 1,500, and we get in terms of hours, here most of the things would get cancelled. This 7 has to be written in the numerator. I leave for you to solve this, and we get the time to be 2 hours. So the time required to raise the water level of the pond by 21 centimeter is 2 hours. Question 9. A solid iron cuboidal block of dimension 4.4 meter, 2.6 meter and 1 meter is recast into a hollow cylindrical pipe of internal radius 30 centimeter and thickness 5 centimeter. Find the length of the pipe. Here the length of the pipe is same as the height of the cylinder. Here there are two things given. One is a cuboid, it's a solid cuboid, and one more thing given is a hollow cylindrical pipe. Which is hollow in nature. I'll write hollow cylindrical pipe. So when it is a hollow cylindrical pipe, we have two radii. One is the internal radius and another is the external radius. Here the internal radius is 30 centimeter, and since the thickness is 5 centimeter, the external radius is 30 plus 5, 35 centimeter, and we require to find the height of this cylindrical pipe. For the cuboid, they have given the length to be 4.4 meters. Since these are in centimeter, it's better converting this as centimeter. 440 centimeter. Breadth is 2.6 meter, which is 260 centimeter, and the height is 1 meter, which is 100 centimeter. Since one is recast into another, volume will remain same. Volume of cuboid will be equal to volume of hollow cylinder. We know the volume of cuboid is LBH and the volume of hollow cylinder is given by pi r square h. Here it is pi h common, we get r2 square minus r1 square. So h will be equal to LBH divided by pi times of r2 square minus r1 square. L is 440 into P is 260 into H is 100 divided by pi value. Here it is 22 by 7. The 7 will go to the numerator into R2 square is 35 square minus 30 square. So 35 square minus 30 square. Again, this particular thing I'd leave it for you to calculate. If you calculate, you'll get the height of the cylinder as 112 meters. So the length of the pipe is 112 meters. With this question, I'll end today's session. Thank you.